Hello again, ladies and gentlemen. Mr. Johnny here, going over some 16.3 and 4 problems here, the objectives. Feel free to pause the video, look them over, come back to them at the end of the video, and see how you feel with them. All right, so taking a look at number 1. It says the molar concentration of hydronium ion in pure water at 25 degrees is what? So remember, hydronium is the H3O plus ion. So in pure water, it's simply 10 to the negative 7 molar. So that is your final answer. You got to remember that the Kw for water is the H plus or hydronium ion concentration times the concentration of the OH minus. All right, and at a pH 7, at neutral pH, that Kw at that temperature is 10 to the minus 14. All right, well, if those two things have to equal each other, then it's got to be 10 to the minus 7 molar for each of those things. Now, if we take a look at Kw, it says the magnitude. So we're talking about the number of it. It's 1 times 10 to the minus 14. Tells us that, well, remember, Kw doesn't tell us anything about really the speed, slowly or quickly, so that gets rid of A or B. But it does tell us about the extent, how much water is ionizing, how much water is breaking down into the H plus and an OH minus all on its own. Because this is such a small number, at minus 14, we know that it's only to a small extent. All right, it doesn't really break down a whole lot. So number 3, what is the pH of an aqueous solution at 25 degrees Celsius containing this concentration of hydronium ion? So here is the key. You got to go, all right, well, what is pH? You got to remember that pH is the negative log of the concentration of, H plus. There we go. And they gave us the H plus, or actually the H3O plus, which is H plus ion concentration of that. So we just plug it in. pH equals negative log of 3.98 times 10 to the 8th, or negative 8. And that gives us 7.4. That's it. All right, so we take a look at number 4. It says, what is the pOH of an aqueous solution at 25 degrees Celsius that contains that much hydronium ion? So we gotta, all right, well, pOH is pretty much the same thing as the pH except for OH. All right, there's also another formula that's probably a little easier to use for this one. It's that the pH plus the pOH has to equal 14. So if we're trying to solve for the pOH, it would just be, pOH would equal 14 minus the pH. And we know that the pH is negative log for the concentration of the hydronium ion, which they gave us right here. So what we're going to do is we're going to just plug that in. So pOH was 14 minus negative log of this number. And you get the answer of being 5.58. And that's your final answer. That's it. All right, 5. Which solution below has the highest concentration of hydroxide ions? So you got to remember that hydroxide is OH minus. So if we're talking about the highest concentration of that, we're talking about the most basic. So which one of these pHs would be the most basic? Well, it would be the highest pH. So the highest pH out of all of them is choice D, 11. All right, 6. The H plus of solution is this moles per liter, aka molar. The pH of the solution lies between, all right, so they're looking for an estimation. Now what's really helpful to be able to do is to look at the number for the concentration and just quickly estimate, not necessarily plug it in, use the log, and just go, all right, well, I know if I had 10 to the minus 4, well, that goes to a pH of 4. If I had 10 to the minus 5, I'd have a pH of 5, so on and so forth. So I'm looking at this. I know that it's going to be around 5 because that's to the minus 5. Now this number is larger than 1, so I know it's more concentrated than a pH of 5, but it's not quite as concentrated as a pH of 4, so I'm in between. So it's going to be in between 4 and 5, right? So if I had, let's say, 10 to the minus 7. If I had 1 times 10 to the minus 7, that would be exactly a pH of 7. If I had 3 times 10 to the minus 7, Well, alright, that 3 is telling me it's more acidic than 7, but not quite acidic as 6. So I know it would be in between 6 and 7. Alright, just like out here, the -5 tells me that, alright, it's around 5, but this 8.34 is telling me it's more acidic than 5. So it would have to be in between 4 and 5. Alright, 7. What is the H plus concentration of a solution whose OH minus concentration is that? So this goes back to knowing that the Kw equals the concentration of H plus times the concentration of OH minus, and that has to equal 10 to the minus 14. So we know the OH minus, so we plug that in. We got to solve for that. So H plus equals 10 to the minus 14 divided by the OH minus, just doing a little algebra there. And now it's just a plug and chug. And I get the answer to be 1.07 times 10 to the minus 13. That's it. Alright, 8. pH of an aqueous solution at 25 degrees Celsius, about room temperature, is 11.4. What is the molarity at H plus in this solution? So this is going to take a little bit of algebra with dealing with logs. So we know the formula is pH equals negative log concentration of H plus. But what we're trying to find is this H plus. So we're going to have to rearrange this stuff to get H plus by itself. First thing we got to do is get rid of the negative sign and get it on the other side. So did that. Now we got positive log of H plus equals negative pH. Now logs, unless written otherwise, you can safely assume that it's a base 10. So what we've got to do to get rid of this log is put the other side to 10 to the. So it's 10 to the whatever was there, negative pH, equals the concentration of H plus. So now we just plug that in. So it's 10 to the negative 11.40, and we get the answer being, where did I put that? 3.98 times 10 to negative 12. Unit would be molar. And that's how you do that. Alrighty then. See you in class. Bring questions. Okay, bye.